and inspire us all, especially our faculty members who can take back immense knowledge to empower their students for the industry of tomorrow. Ladies and gentlemen, with a huge round of applause, let us welcome Mr. Animesh Aaryan sir to the virtual stage. Sir, welcome.
Yeah, good evening, everyone. Thank you so much for this kind introduction. I would just want to know if I'm audible and clear, right? There is no connection issue because I'm traveling.
Yes.
Okay, great. So maybe I'll start with a vote of thanks to Sri Naresh Garu because he is someone who has pulled me into this, and was more than happy to come on. Okay. Now, what I would start with is, before I go with the technical presentation and why space-based quantum safe communication or satellite-based quantum communication is essential for our country, maybe I'll start with a couple of questions just to understand the audience, right? I believe most of you will be from an engineering background, right? Most of you. Is that a fair assumption? Okay, great.
Yes, sir.
And then by and large, all of you would be understanding that how technology has shifted in the last couple of years, right? You can look at what AI is doing, right? Something which is unimaginable, right? It is changing the landscape of every field, every stream, whether you go from aeronautics to medical sciences to finance to anything, you name it, it is already changing it, right? Now, if you look at quantum technology, even that has got a similar kind of impact, okay? It is just that some things are getting realized in this process. So it is like we are in the early years of quantum technology, okay? Needless to say that after, if you look at it from a defense perspective, after land, air, and sea, space is the fourth dimension, right? Especially in the warfare side, space is the fourth dimension, and anybody who is able to capture this dimension will be actually leading this, race, right? So recent events, if you look at what has happened with the conflicts, within our, with India, or we see conflicts around the globe, space has played a very important role. Whether we look at drone-based, tactical communication, or asymmetric warfare, space becomes a field which is only expanding as we speak, right? So what I will talk about here is that I will talk on three major bullet points. I will try to highlight, how quantum technology is shaping up. Why we should be worried about our data, and how can quantum communication save us? And then what are the challenges? Challenges are also an opportunity for all of you, right? If you are able to write a better code than ChatGPT, you know that there is a lot of things to be done, right? So what we will do is that we will also keep it a little open. So maybe I'll take some momentary pause when I talk, and you can actually ask questions if you have any. Okay? Yeah? Okay, 1 minute. I'll start sharing my screen. Yeah. Visible to you guys?
Yes, sir.
Okay, great. Okay, so now, how many of you know that this year has been announced as the year of quantum science and technology, the International Year of Quantum Science and Technology? Okay, so I would only say that it is only more than coincidence that we're also talking about how quantum technology is relevant at KIYE, right? So the next 10 years are also going to be crucial, where you will see a lot of developments in the field of quantum computing, quantum communication, quantum memory, and broadly on quantum sensing, right? So we will also usher into a new era of something called as quantum internet, where you will have distributed quantum computing, communication, everything at place, and it will be unimaginable. Like, for example, if you look at today's communication, today's internet, it started from a small lab, a defense lab in the US, right? Nobody thought it could escalate, it could, grow into something like this, right? So that is on the, like, what we look in the next 10 years, right? Every other country is making a lot of efforts, okay? If you can look at this, every country is trying to, gain their own technological strength, and more than 42 billion is already being, spent on all of this. Of course, China is leading the race in this technology, with more than 1/3 of the investments only they making into quantum tech. Okay, this only emphasizes, how relevant this technology is. As a company, we work on building quantum enhanced solutions. So we have our offerings in quantum secure communication, and we are working on customized solution on sensing and imaging. Okay, I will go to the vertical of quantum secure communication, which we also abbreviate as QSC. Okay, now ask this question to yourself. Okay, do you have a data which is relevant to you for a longer period of time? Do you know what is the impact of quantum computers on your data? Do you know your data is being harvested? And do you know if your data is being harvested to be decrypted at a later point of time? If any of your answers is relevant to the response column, which is yes, then you are actually at a huge risk. Okay. Now look at, for example, okay, look at this. Most of the communication is designed on public key security, and if you look at this, the time to break a key is close to about 300 trillion years on the fastest supercomputer. Now, this is a very conservative estimate. Everyone will feel that this is too much, right? You don't have to worry, 300 trillion years. Now, bring quantum computers into the perspective, and you will see actually that same time now can be reduced into a couple of hours using quantum computers. So from 300 trillion years, we come down to a couple of hours using quantum computers. And that's why security is very relevant to us. So whatever we think of security is already challenged because of the current systems. Okay. So we have to move to a more safer and secure platform. Okay. Now think about the consequence of this, right? You are trying to use satellite for, collecting some data, which is relevant to only your country, which is, but someone else is able to intercept every piece of information and decode it. Do you see the risk what it poses? Imagine all of data being stored by somebody else, and we can't even let that happen. Think of drones being, drones are being, capable of being controlled by somebody else, right? Isn't this a huge security threat? Imagine that, so many people are now getting into so many scams already, right? Digital scams, and now add a quantum layer, it becomes even more complicated. Okay, so this is the current cybersecurity scenario, right? So you have very sophisticated attacks. You have nation-state actors. Now AI is already playing a major role in making the vulnerability even more worse. And you have additionally quantum computing risk, right? So all of this becomes very, very convoluted, and we have to understand that if we do not control our data, we will eventually become a digital colony, right? Imagine that people are able to understand that what exactly you want to talk about and then be ready with it. So everything with respect to privacy, confidentiality, and sovereignty of a country is at risk if you don't safeguard your data. Imagine a time, when our grandmothers used to have that, maybe 9 lever, 10 lever locks, to store gold. If you don't do that for your data, you're only going to expose yourself, right? That's the context. Okay, so this is the current scenario, which means that quantum computers are becoming extremely powerful, and the threat of hacking cannot be ignored. So any classified data is with 5+ years is already at risk. The first victims are obviously governments, defense, banks, big MNCs who are holding bulk data, right? And so therefore you need a safe plan to ensure yourself against quantum computers. Okay. Now, is this anybody, any questions till this point? Anyone? So you understand the risk, right? What is happening, which means that whatever algorithm, even your WhatsApp communication, all of these are not designed to be safe against quantum computers. Okay, so your data is getting harvested and will be used at a later point of time. So we must assess the risk and come up with solution to safeguard ourselves. Okay, like you do some kind of a safety migration plan. Okay, so this is the problem. Okay, now what is the solution looking like? So you see on your left hand side is asymmetric cryptography. Anybody one from communication side here? I'm sure that people from computer science background or electronics communication will know about public key cryptography. So all that you would have studied is actually not secure today. And you need to go with only two kinds of solution, which is going to safeguard you, which is a software-based solution based on PQC, which is called as post-quantum cryptography, highlighted in blue, and a hardware-based solution called quantum key distribution, which is only the way to save yourself from quantum attacks. Okay. Now I will go to what is the market, right? So you can see the market for this is, it's visible to you, right? So you can see, slowly you will see a natural upgrade into a lot of these areas, right from data centers to governments, to Industry 4.0, to drones, and then also towards satellite. Now, I think your theme is satellite communication, right? Now, satellite being such a vast, space being such a vast area, managing satellite itself is very difficult. Now, imagine you also want to do secure communication, right? And the advantage is that if anyone is trying to intercept your data, you can detect the presence of any third party, any adversary immediately. So that is the advantage of using a quantum safe communication system. So you can detect the presence of any eavesdrop. Okay. Now, 1 second. This is where you have the terrestrial links, right? So you can see it's an extensive fiber communication link. Even this will get upgraded, into a quantum safe network. Okay. Now I'll come with some challenges which is relevant, especially on the space side. Okay. Now, if you look at the current scenario, one of the challenges is that when you want to secure your space communication, right, you encounter so many challenges in this. Okay. The challenges start from understanding the atmospheric interferences. You have a very India being a tropical country, right? You have a very cloudy environment, right? Very dusty environment, a noisy environment, so to speak, right? And these actually hinder your signal. Okay, so your noise levels are very high. So that is the first technical challenge. The second one is that your environment is also changing, right? If you go to Delhi, you have smog, in the winters. You don't even have a visibility of more than 100 meters. Think about how will you communicate safely through a satellite. Okay. So the environment in India is also very diverse, right? From Kashmir to Kanyakumari, you will have a completely different environment. Or whether you go from Assam to or Arunachal to Gujarat, right? Now these environmental factors play a very critical role when you want to establish a real time working link. Right? The third part is that the pointing and tracking systems. I think people who are from aeronautics, I think Siri is from aeronautics, I think, if I heard your introduction correctly, right? Now how pointing and tracking systems work, right? So the longer you go, right, your change in your the accuracy that you want to achieve in any system. So you want to put a quantum payload and you put it in satellite. You can't send a man, right, to repair it, right? So your pointing and tracking systems must be very accurate for that matter. Okay, that accuracy defines that how precise your communication is going to be. Okay, the third part is that of course noise performance and access duration, because when you are using LEOs, right, the low Earth orbits, then you only have a particular window to talk at every point of time, right? So let's say you want to go from one point to the other, you have a very small fraction window. Okay, so this is the other challenge, right? Now, in addition, we have engineering challenges, which means that how do you make a system? So maybe you're working in a lab it's a closed environment, you do not worry. But when you want to send something into space, you have to make it space qualified. You also have to ensure that it's immune to radiations. You also have to ensure it is fault tolerant, right? And then automated. At the same time, also having a degree of control onto that system, right? So this is one of the major challenges, which is actually, stopping us to achieve that resilience into space. Okay, I'll give you some pictures of relevant things. Now, look at the global developments. China has developed an extensive 12,000 kilometer of quantum safe fiber communication. They additionally have 2 satellites called Mission 1, Mission 2. They are quantum satellites. They ensure that they are able to safely communicate all their defense transactions, right? Now, this is I would say, the technological prowess, which is, seen globally, right? So they have been able to develop quantum satellite, quantum payload, put it in a satellite and achieve safe communication. Now, anybody who is trying to intercept this communication, they get to know that immediately. This is also happening for all 6G and 5G networks, where quantum becomes a base layer onto which everything becomes secure. So I think this fundamental, proposition, right? So I think in the schools also they say, right? If your base is strong, anything you built on the top of it is going to be strong, right? So if you build a fundamental layer, physical layer using quantum systems, anything that you build on top of it, especially from a cybersecurity perspective, is going to be only stronger because that becomes the fundamental block of your cryptography, right? This is going to be also, and maybe I take a minute to talk about that everything which we do today as a company, right? So we have been working in this field for the last 7 years, and it's extremely difficult to do something in this space, extremely difficult, okay? The kind of engineering challenges, and therefore it is also an opportunity to all of you. So if you're interested into this field, you want to work with us, feel free to write it to us. You can collect my email ID from Naresh Garu, and you can look at how we can actually have bright students work with us. But any roadblock is also an opportunity. So we face these roadblocks. I can only tell you that people have been able to do it outside India. There is no reason why we cannot do it. You can see in the last 10 years, we have been able to do some of the most fantastic work, right? When you look at the missile technologies developed by the defense, if you look at the technology on the fintech side, right? You can look at how smooth our payment gateways are, right? Everyone is trying now want that if they can have a phone pay or a UPI for their interfaces, right? So India is able to do things innovatively, and there is no reason that why we cannot achieve this kind of advancement in the space. I mean, that is definitely going to happen. As a company, we are open to everybody, okay? And what we want, one of the motives behind starting this company is also to ensure that we achieve what you called as technological technological strength and capability, and also have independence. Because see how ISRO became now a worldwide name is also because nobody shared the technology with us, right? In the early 80s, okay? And so ISRO started doing everything by its own. It took a lot of time, but now they're able to do things way more efficiently than the counterparts outside, India, right? So that is the achievement of ISRO. Now, what we have to say is that as a country, this is only one side of the story, right? We have to become independent and I would say self-reliant in every technological field, right? And space is something which we just can't leave open. Every communication which we do today is through space only, right? I mean, broad communications, and going forward, every data, so I believe that space touches us in one way or the other, okay? Whether we look at our GPS navigation, cannot happen without that, right? Whether we look at monitoring our doing a weather monitoring, right? How will you do it without satellites? So space is a dimension that we can't just afford to be led to somebody else, right? Let somebody else control the game, right? Let somebody else control our data. So this is my kind of input to everybody. This space is only getting more and more excited with AI coming in, with quantum coming in. There are only more opportunities to work. Okay, if this area of secure communication attracts you, feel free to write to us. Okay. Now, what I will do is, you can look at this, right? So you can look at the backbone network. You can see satellites here, right? Mission 1, Mission 2. Okay. Now there is something called, we call as the road to quantum safe journey, right? So this is relevant for all of you to understand that unless we know who we are, we can never go where we want to be, right? So let's say if you are weak in one of the subjects, you have to figure out, right? The first part is always discovery, discovering that what are you made of? So similarly, when you want to do a quantum safe communication, the first step is identifying what is your inventory, then create a roadmap, and then go towards migration, and then testing and maintenance, right? So this is some of the things that we are working with the armed forces, with the defense here, is actually to realize that kind of critical infrastructure required for quantum safe communication. Okay, so I have couple of more slides on this part where you can see that quantum safe communication is not a choice now. Almost all countries now are making this as a default for their browsers, for their operating systems, for their networking devices. And in the next 5 to 7 years, you will see a complete transition actually to quantum safe methods. Okay, so if you look at what is going to be the new world, right? I think this slide will be relevant. Okay, quantum technology. Is this visible to you? Right, so you can see right from satellites, being used for quantum communication, you also have a quantum radar, to do a better scanning of all the assets. Then, you also look at quantum computing, quantum cyber warfare, doing an underground, mapping using, quantum systems. Then how many of you know actually that there are ways in which your GPS can be jammed? Are you aware of this? You can see in certain locations, your GPS doesn't come, right? You get a very poor signal if you go to the basement and all, which means that your GPS can be jammed as well. Okay, that's why jammers are there. Now, quantum gives you something called as GPS-free navigation systems, which will be very relevant in case you do not get a connectivity. How will you ensure that you're going in the right direction? So that's where GPS-free navigation will be very relevant for automotive sector and also for Navy for that matter, right? So this is quantum inertial navigation and quantum electronic warfare. Okay, so you can see the entire I would say map is going to be changed because you will see developments happening on all fronts using quantum technologies. We work on quantum safe communication, which itself is very extensive, but you will soon see that how, you can see, right, how now AI, you can spoof any video. You can actually make so many things just by taking a couple of pictures, right? It had become very crazy and very scary as well, right? Now, think about that if doing all of this in a way more shorter time, way more efficiently, right? So obviously everything has got a good, technology is very blind, no? The same nuclear technology can be used for power production and also be used as a weapon, right? So quantum also, it has got extensive benefits, but at the same time, it also exposes and makes our risk even higher, in certain ways, right? So you have to use quantum to fight quantum. kind of an example. Okay, so with that, probably, and what I would probably just talk about what are the applications probably, of quantum secure communication. So you can see the applications are for all strategic requirements, whether we look at, defense, government, or let's say data centers, finance and banking, healthcare, space and mobile communication. So I don't know how many of you know, but your phones actually, the Samsung phones have now, for their 6G phones, they have introduced a quantum chip into it, which will be responsible to create a unique key for your communication. Okay, so this is something which is happening not tomorrow, not day after tomorrow. This is already happening and in progress. Okay, so you can see, right, that almost for all secure purposes, we would need a quantum safe, systems in place, and that actually is also required to keep the sovereignty of our country intact, right? So we can't give our data to bad actors. We can't let them control. I don't know, you have seen probably, if you just talk about maybe having a party, then some restaurants and ads will come up. Probably you would have seen this, right? So you already know that so much of data is getting exposed, right? Imagine that people are able to hear almost everything. Isn't that scary? And therefore, isn't that a mission to be achieved, that we achieve, quantum safe communication in space? So I believe I was given 25 minutes. I've been able to wrap it in that, and I'm open to questions. Okay. So yeah, but a dialogue would be more helpful. And probably I can give better insight. So probably I'll stop my presentation here. Which is, yeah, and you can probably, anybody can note my email as well. No problem. Okay. So yeah, so over to the organizer. Feel free to ask questions, and if you have any hesitation, you can email it to us. Okay. Yeah, but yeah, please.
Thank
I'm
you,
open.
sir. That
Yeah.
Yeah, thank you, sir, for that deeply insight and inspiring talk. Your words add value to the young mind's future. Thank you so much, sir. Now I request our guest Animesh Aaryan, sir, to take few questions from the students. We now open the floor for a short Q&A session. If you have any questions, please drop them in the YouTube live chat and we'll address few questions right now. Sir, there's a question from my side. Sir, as you told that you are already into space field since 7 years, and it is so much difficult to work out in space field. What were the major difficult for you, sir?
So, okay, maybe I'll rephrase that position. So what I had mentioned is that we started in 2018. Okay, so the initial years were actually used in developing the product, and you don't also develop a product overnight, right? So we had chosen fiber-based communication products. So now we're also entering into the space-based communication. And we see that fiber itself was very challenging, right? When we have everything in our hands, okay, is a challenge, right? Now, when we go towards space side, when you have very limited control, making something space ready is very complex, and it's a very complex mixture of understanding different systems, right? So that is something that we are on the path, and once we achieve, I would definitely want to come back and give you more insights. But majorly, it is making something space grade, space qualified, is a very ardent task. It's very difficult to do something because you can't keep on. Imagine that you can't keep on sending satellites also, right? So you do want to test everything before, and then now imagine I'm putting a payload inside the satellite. It's also very expensive. So that is something that's challenging. Apart from, of course, the financial side of it, the technical challenges are also quite high. Yeah.
Thank you, sir. Sir, there's a next question from Alekia. Sir, can you explain how quantum theory is helping in artificial intelligence or big data?
Okay, good question. So I will rephrase. So what your question is that, is there any way quantum technology can play a role in AI or big data? Is that the correct thing probably? So if that is the thing, I can tell you that everything actually which you, so no matter, who is organizing this, right? There is a machine which is running, right? So when you type something on ChatGPT, there is a backend machine running, right? And these machines, these servers, have a cost to it, right? Because nothing is, it's like it will be running on 24/7 electricity, right? You need to cool them down, right? So there's a huge power consumption. So there's a cost of compute. Okay. So everything that you do, there will be a cost of doing any computation, anything, right? Because your system is running basically to millions and millions of users, right? Now imagine that you can run that more efficiently, because quantum computers can reduce something which is taking days to a couple of hours. So your cost of compute will go down. Okay, and therefore your AIs can become way more faster. Okay, that is the impact of quantum and big data eventually. So eventually, no matter what you do, right, big data, you have to crunch the data, right, to get something meaningful out of it. Then you have to wait for the system. So has it happened to you? You want to do some simulation. If any, I think again, if any one of you have done simulation, it runs for some time, right? And running would mean that there is electricity which is going, the bill which is shooting up. Now, if you can do that in way more efficiently, you actually reduce the time and therefore save money, right? So this is just one aspect. The second aspect is that there are many. So if you do, for example, I will take an example of drug discovery. Okay, so when you do a drug discovery, it takes about a decade, right, from starting from a candidate, then doing some limited trials on animals, then eventually going to human trials, right? Now imagine you can simulate all your chemical reactions onto a computer, because they're capable of doing it, right? You can reduce your time to qualify any candidate or remove any candidate. Probably this will not work, right? That is another dimension. Okay, so if you look at it, quantum computers has got a lot of positives to it, a lot of plus. The only negative probably, which is that it exposes, because it is powerful of doing any computation way more faster, then it is also able to decrypt your keys way more faster, right? So that's the downside. Yeah.
Thank you, sir. Now I request Ms. Shruti to present a question.
Sir, good afternoon, sir. I'm Shruti from Chemical Engineering domain. So, sir, I have one question. You were saying about simulations. So basically, simulations are from many types. And if it is from my background, simulations can be from maths, simulations can be from making a product. So how does it work in quantum theory? So like, will that be useful in making the code or in the front side?
Okay. No. So this is how you understand. Have you tried using a cluster or a high performance computer?
No.
The same code can run faster if you have faster compute, right? This is a very standard thing, okay? So if you need X amount of resources, okay, to run something, okay, and X amount of resources will take time t, okay? Now, if I'm able to give you a faster processor, then that t can be reduced, right?
Yes.
Without changing the codes, okay? I'm just saying, I can process that information faster, parallel, right? So think of this as an innovative way of doing parallel, computing. Okay. Therefore, a larger problem is broken into smaller pieces and then approached to be solved simultaneously. Okay. So you reduce your, runtime for all of this. Okay. Of course, it won't be the same way, in the sense that same codes won't work. So that's why there are companies working on making quantum algorithms which can actually run efficiently on quantum computers. Okay. So definitely, see, our traditional computers are good for almost everything. Okay. But wherever we want, for day-to-day affairs, for regular things, extremely good. But when we want to solve a difficult problem or a complex problem, right, that's when it becomes difficult. Okay, so you have to have a better compute facility. Okay, and today the regular computers have also reached the threshold limit. So you can see that your chips are already 2 nanometer. Beyond that, you will go into the atomic range. So you have also reached the fundamental limits of your, your traditional computing. So you can only add multiple stacks of it, but fundamentally, you can't put more and more, let's say transistors in that area, because now beyond that it goes into the atomic range, and therefore, your gates, your traditional gates won't work the way they were designed to work. Okay, so this is another way of computing. So this is which we call as the third wave of computing, which is quantum computing. The first wave was when you had those electrical systems, right? If you would have seen this movie or imitation game, or heard of the machine Enigma, right? They were electrical devices performing computation. Then the second wave came when you had semiconductors, right, which we use today. Now this is the third wave of computing, in which you will have quantum processors, which will work in a different way. Yeah.
Yes, sir. I got you, sir. Thank you, sir.
Yeah.
Thank you, sir. Now there's a question from Akshita Manthani. Good evening, sir. What are the main challenges in scaling up quantum communication networks?
Okay, that is also very precise, but yeah, good to know that people have this precise question. So, see, fundamentally, when you want to do quantum communication, right, you will build these transceiver boxes, right? The way classical communications have classical transceivers, quantum communication has got quantum transceivers. So one of the challenges for us is to actually do long distance. Okay, so we are able to do, let's say, hundreds of kilometers, point to point kind of a thing, right? Now you want to extend it beyond that, so you need to work on making it better. The second thing is that when you want to do that on fiber, okay, which is a guided media, you have a challenge of, achieving, you will have a lot of repeaters in between, right? Those repeaters will increase your noise also. So you have to have quantum repeaters in place, which is still a technology under development. It has not been developed. Okay. If you do the space side, I think space side I had already covered that, what are the challenges. But on the free space side, fiber-based side, the challenges are also that, every day if you go through your colony or your home, you would see roads being dug up. Right? So then they also cut the fibers, right? So fibers are also having multiple joints. Okay. So that also poses a problem because your losses increase. So when the losses increase, your signal will also go down, right? Your signal to noise ratio will also go down. So that also, these are some field, limitations. But from a technology perspective, it is also that, when first thing comes, the initial mobile phones, you could see only a black and white message was good enough for us. Right now, having smartphones, so the technology will also evolve slowly, where you would see that a larger adoption and implementation of quantum devices.
Thank you, sir. Now I request Ms. Samia to present a question for our guest.
Good evening, sir. Myself Samia Mirza. I'm from the pharmacy background. So I would like to know, sir, how is quantum technology being used in knowing the chemical side effect, ADR, or a chemical reaction? How is quantum technology being used in pharmacy side, in pharmacokinetics, toxicology, or drug design? I would like to know about it.
Yeah. So Samir, I think some bit of it I already covered, that how it is relevant. But I'll tell you typically what happens now, that when you want to create a drug, okay, then you will have maybe 3, 4, or 10 tens of candidates. Each of the candidates has to work in a certain environment to produce a desirable result. And if it is not suiting your eventual goal, then you remove them. So you will divide them into multiple stages, right? So let's say you take a medicine, you take it with water, it gets dissolved through your enzymes, and then you eventually reach your blood vessels and all of that. Now imagine if today what we do is that we made a drug, then we will test it. Is there any reaction? Then we will go with animal trials, right? We'll feed a mouse, right? Now we will see. Then we will see which is the closest, genetically closest to us. Try on them,
exactly.
right? Study them, and then come back. Now imagine if you had the capability to simulate each of these environments and run your product through it, right? So that reduces your time, right?
Yeah.
Which gives you that, okay, if something is
basically, yeah.
So you're able to study the reactions of it without the 10-year long period, okay? Right? So that is the advantage. And that's why every other tech company is actually working to make large-scale quantum computers, because they can solve a lot of the problems like this. Like, for example, the DNA is made of, is the protein foldings, right? These protein foldings are very important, and simulating them is very hard. You can't run it on a classical computer, but quantum computers will be able to do that. So the moment you go to the fundamental level, you are able to address at the fundamental level, then you take it forward. It's easy. It is not, so let me tell you, the theory is, the math supports that this all can be done, okay? But when you realize the technology, many of the challenges will also come, right? That making an efficient quantum computer, making a large-scale quantum computer, making better algorithms which can work, right? So therefore, definitely there is a way of lot of R&D activities already happening worldwide. Like a Japanese firm is trying to create a new polymer to build its tire, okay? Which will be better in terms of all the measures, right? So that they're simulating using this. And therefore, they'll have some metrics to it. Yeah.
Thank you, sir.
Yeah.
Thank you, sir. Thank you, Samya. Sir, there's a next question from Vinay from Mahavir College. How an aeronautical engineering can start career in quantum technology?
Okay. So I think any engineering field for that matter, okay, if you have learned basic math and let's say basics of whatever this physics that you're studying, right, you can straightforward jump to learn about quantum computing. There are a lot of courses available already, on the internet. Okay. Additionally, if you want a structured program, so if there are if there are unstructured programs, you have YouTube available. But you want to go through a structured course, you can take MTech. Let's say it is available at IIT Hyderabad. It is available at IIT Madras, and I think it is also getting done it is available in ISC and some IITs as well. Okay, I can share this. But if you look at the relevance, where it will come, it is already getting now introduced at the undergrad level by Department of Science and Technology. So DST has already launched a program which universities can opt for introducing at the undergrad level, okay, which is like 1 semester course, which exposes you to quantum technology. Okay, so this is something which is already happening. Unstructured programs, or let's say something you want, self-paced courses are already available. The only requisites would be knowing a bit of maths and this little bit of if you have done let's say your linear algebra, probability, and so linear algebra, probability, and some bit of physics, you're good, not a problem. Which I believe, like all of you do, right? I think in engineering you do study linear algebra, you do study all of it, probability, all of it that you study. Statistics you study, right? So, yeah. So anyone, it doesn't matter. If you have basic maths and you are able to take it up. No problem.
Sir, there's a next question. Thank you, sir. Firstly, there's a next question from Sindhu. Sir, can you suggest any certifications or internships that will help students to gain practical knowledge?
Okay. Yeah. So, so when I say quantum tech, right, it is split into quantum computing, quantum communication, quantum sensing, and quantum memory. Additionally, quantum algorithms as well, right? So for quantum computing, you already have a lot of courses, launched by IBM, certificate courses from IBM, and then I think also Bracket also does it. So there are these courses available. If you look at quantum communication, you will have to align with some research labs and startups which are working in this field. So, you can definitely kind of, opt for something like this. Yeah, is someone saying something? Yeah. I hope I have answered that question.
Yes, sir. Thank you, sir. Sir, then is the next question from Alekia from ACE Engineering College. Are there any specific courses or degrees we should pursue to enter this field?
Okay. So, what's the name of the person?
Alekia, sir.
Alikya. Okay. So, see, any field, if you want to go to the depth, you would eventually need a structured course. No doubts about it. But if you want to just expand your horizon as to how the technology is relevant, like most of us, I have not taken any course on AI, but I have read, I have understood, and know something about how fundamentally it works. Okay. So I'm like, let's say at a horizontal level. Okay. So if you want to be someone who is, let's say, a generalist who knows many things, you do some bit, right? But if you want to be a tech expert, you have to deep dive, right? So then you have to you have to do eventually a course, then work with industry, research lab to gain that depth. Okay, but there are courses available to give you a broader understanding as well. Yeah.
Sir, thank you, sir. Now I request Fanindra Sharma to present a question.
Good evening, sir. Sir, I have the question, what is the primary advantage of using quantum key distribution in space communication?
So, I think this probably I highlighted. See, what are you sharing through space? Is it to be known by everybody? If it was known to be everybody, why do you even have to encrypt your data? So you do know that you are sending something confidential, right? Now, if you want to share a piece of data, let's say to Shruti, physical data. So you will take a printout, lock it in a suitcase and give it to her. And then through phone, you will tell that this is the passcode. Or this is the password, right? Now, imagine if someone is able to guess, because I know that Fanindra always keeps his roll number as his passcode. Then I did not have to break your suitcase. I was able to guess your keys. Right? Now, imagine that your suitcase lock I am not able to open, but if I just hit I punch, with one punch it cracks open. Then also I don't need your password. The third thing, you send that suitcase to your friend. I bribe your friend to tell me all of that, and he gives it to you. Right? So your channel, your passcode, your algorithm, which is your suitcase. If I can crack any of this, your data is exposed. So whatever methods which are being used today, whatever algorithms which are used today for space communication, they will not withstand quantum computers. So you have to come up with a better way to communicate. And those I told are only two ways. One is post-quantum cryptography, which is an algorithm-based, a quantum-safe algorithm-based solution, or you have a hardware-based solution, where you rely on fundamentals of physics. So I state an entangled system, which means that they are twin brothers. One brother, I keep it with myself and I send the other to the recipient. If someone is intercepting, then the brother will also show the behavior. If you have seen the movie Jova, probably you will be able to relate. Okay, so you tamper one or hit one, the other person also will actually feel it, right? So that is the uniqueness of using this. Okay, and that's why, so the relevance is that if your data is not critical, if your data can be known by everybody, okay, no problem. But when you want to secure your data, you will have to do it. So it's relevant for banks, it's relevant for data centers, it's relevant for healthcare. Do you want that everybody should be able to access anyone's healthcare data? What medicines you take? So now every data is available when a lot of these AIMS data centers were attacked. Right? Now imagine if I had safeguarded in the most secure way. Okay, you have it, you can't open it anyways. Right? So what we are saying is that your data is getting harvested. Okay? And therefore you must have a way to ensure that they're encrypted in the best way possible. Okay? Which is through these methods. I hope I have answered that.
Yeah, sir. Thank you, sir. Sir, before going to the next questions, I would like to take permission. Sir, can we have 2 more questions?
Yeah, please, no problem.
Thank you, sir. Sir, there's a next question from Siddhika. Good evening, sir. What device is being developed to extend the range of quantum communication?
So if you look at fiber-based communication, it is point-to-point above 100 kilometers. It is hundreds of kilometers, but it can be extended into 500s and thousands. So it is just a network topology. So it's only relevant that how long you want to put it, right? Yeah.
Thank you, sir. Sir, there's another question from Samia. Is quantum technology being used to model chemical reactions or predict drug side effects?
I think it is self-explanatory, right? So when you see that you're able to study something at through chemical reactions, that there is there will be a primitive indicator of the side effects, right? So if through some reaction you are releasing, let's say, some poisonous element or let's say poisonous gas, it's going to be harmful, right? So there are primary indicators to study the side effects, and also complex environments can also be simulated. So as I said in the beginning, if you are able to, so your let's say your skin membrane eventually is made of tissues, right? Then those tissues have cells, and those cells eventually will be made of some or the other chemicals, right? So if you're able to go to that level, you can mimic a lot of things. That's why I actually talked about protein foldings. Okay, even at at that level you can address something. So this is something which is very much in place. People are really doing a lot of work. Yeah.
Sir, thank you, sir. Thank you so much for those interactive answers. Your answers were inspiring and motivating. As we close off this remarkable session, I invite Ms. Riti to present the vote of thanks. Ms. Riti, over to you.
Thank you, Deepshika. Good evening, everyone. Good evening, sir. I am Shruti Ravinder, pursuing chemical engineering from Chaitanya Bharati Institute of Technology, CBIT. It is my privilege and honor to deliver the vote of thanks for today's insightful session of Aryabhata Space Utsav lecture series, hosted by Kalam's Institute of Youth Excellence. At the outset, I would like to express our heartfelt gratitude to our distinguished speaker, Animesh sir, CEO and co-founder of TAQBIT Labs. Sir, your talk on quantum communication and space technology was thought-provoking and truly forward-looking. You've not only shared cutting-edge knowledge, but also opened doors for young minds to think beyond boundaries and explore the emerging frontiers of secure space innovation. I would also like to take a moment to sincerely thank Dr. G. Satish Reddy sir, former chairman of DRDO and a constant guiding force behind the KIYE Foundation. His mentorship has been instrumental in shaping the vision and direction of our mission. We are also deeply grateful to Prakash Chauhan sir from NRSC ISRO, whose guidance and support have been pivotal in curating the Aryabhata Space Utsav lecture series, helping us bring world-class learning to the student community. A special tribute to Dr. APJ Abdul Kalam, whose life and vision continue to be the cornerstone of everyone we strive for. His dream of empowering youth through knowledge and science remains at the heart of this initiative. Thank you to KIYE organizing team, our technical volunteers, and enthusiastic audience, and school and college faculties who continue to make this lecture series a growing success. Let us carry forward today's inspiration and continue working with commitment towards making India a global leader in science and technology. Thank you once again, sir, and thank you
Thank you so
all
much. Thank
for
you so
being a
much.
part of this event.
Yeah, all the best
Thank
to you and the entire foundation, and my thanks to every one of you. Okay? Thank you so much.
Sir.
Thank you, Shruti, for those wonderful words of gratitude. And I would like to add special thanks to Director NRSC, Dr. Prakash Chauhanji, for being part of Aryabhata Space Utsav. And I also want to add value to the event by thanking Chairman of ISRO and ISRO family for the guidance and support from NRSC ISRO. And special thanks to Animesh Aaryan sir. And I also thank everyone who joined us. Thank you for being part of Lecture 4 of Aryabhata Space Utsav. Let's continue this exciting journey as we explore new things in science and space. And I request everyone to subscribe our YouTube channel, KIYE Foundation, for future sessions. And also join our official WhatsApp channel for updates and announcements. The next lecture 5 is on 16th of August. Let's stay connected, stay curious, and keep reaching for the stars. Because truly, space is the next destination. Let's explore it. Have a wonderful evening, everyone. Thank you. Jai Hind.
தேசிய கொடியும் அசைந்து சொல்லும் கலாம் கலாம் சலாம் சலாம் தேசம் முழுக்க எழுந்து சொல்லும் கலாம் கலாம் சலாம் சலாம் கலாம் கலாம் சலாம் சலாம் கலாம் கலாம் சலாம் சலாம் தேசிய கொடியும் அசைந்து சொல்லும் கலாம் கலாம் சலாம் சலாம் தேசம் முழுக்க எழுந்து சொல்லும் கலாம் கலாம் சலாம் சலாம் கல்லும் முள்ளும் புல்லும் சொல்லும் கலாம் கலாம் சலாம் சலாம் காலம் கடந்து காலம் சொல்லும் கலாம் கலாம் சலாம் சலாம் கலாம் கலாம் சலாம் சலாம் கலாம் கலாம் சலாம் சலாம்.
You must have a dream, continuously acquire knowledge, hard work and perseverance. You must not be afraid of
சமூகத்தில் அறிவார்ந்த மாற்றத்திற்கு தேவையான பொருளாதார வளர்ச்சி
நேர்மை என்பது